So now let's go over an algorithm that is even faster than the other algorithms that we have covered, and that is merge sort. And merge sort does a sort of intuitive recursion algorithm to make it faster. And we're going to be going over exactly how it does that. We're actually going to be breaking this one up into two videos, one on the intuition behind it because it's a little bit more complex, and one on the runtimes because that as well is a little bit more complex and needs its own sort of explanation. So let's get started. Let's just go through the intuition and then we'll look at a visual model of it running as well. So the way that merge sort works is that it takes the data. So it takes the array and then it splits it into little sub-arrays. So for example, what we do is we take this array up here and let's say that there's just 4 elements of 7, 10, 9, and 8. And what we do is we separate those down into a left and a right column. So what we have here is we have a 7 and a 10, except let's keep the color consistent right here. And let's go like that. So we have a 7, a 10, and then on the right here we have another subarray. And you'll notice that we don't do anything. We're not doing any sorting at this step. We're just splitting it down into its little subarrays. Like so, and then what we do is we split it down again until they are just at boxes that are completely and totally independent of one another. So 7, 10, 9, 8. And then what we do with this is that we recombine it. We recombine these two into an array of 2, and we recombine these two back into an array of 2. And you might be thinking, well, we just split them up. What are we going to do when we recombine them? This is where the sorting actually takes place. So stay with me here. What we're going to do is we're going to create ourselves a cursor on the left and a cursor on the right. And at this step, it doesn't make a lot of sense, but when we get into larger ones, it will start to make sense. So we have a cursor on the left, we have a cursor on the right, and what we're going to do is we're going to take those and we're going to compare those numbers. So right now, the cursor on the left is pointing to a 7, and the cursor on the right is pointing to a 10. So which one of those is smaller? Well, the 7 is smaller, so it goes first, and then the 10 is larger than that, so it goes next. And we're going to do the exact same thing on the right over here. The 8 goes first, or in this situation, the 8 was on the right, so it's actually blue. The 8 goes first, and then the 9 goes right after it. So the 8 goes first, 9 goes right after it. And I know that didn't make a lot of sense, so let's actually make it make sense. It makes more sense when we actually have more elements to sort of track right here. So now what we have is we have it combining it back down into its final array. So we're going to go ahead and create those cursors once again. We have one pointing to the left and one pointing to the right. Like so. And what we do is we take these numbers and we compare the two cursors. So the first cursor is pointing to 7 at the current moment, so it's pointing to a 7, and the next cursor is pointing to an 8. We take these two and we compare them. Well, the 7 is the smallest one, so we put that into the first spot of the array. Now, what we do is we cross that number out. We no longer are using it. We take the cursor and we move it to the next element of whatever array was just used. So since the left array was used, we're taking the red cursor and we're moving it to the right. And when we move it to the right, we then put in the new number. So in this situation, it's a 10. So we put in the new number, we grab both the numbers, and we check again. Which one's smaller? Well, now it's the right side. So we go ahead and we write in the right side. We cross this number out. We move the cursor over. And then we redo the comparison. So now the right side is a 9. So we put in a 9. And then we put in the last element of the 10 on the left over here. And you'll notice during this step, we ran how many times? N times. And during this step, we ran only n times. We didn't run n squared or anything like that because all we did was we just moved the cursor. We touched the 7 once, the 8 once, the 9 once, and the 10 once. And then we touched them again. So it was just 2 of these n's. And this is going to tie into the runtime later, but just keep that in sort of your mind because it's going to, like I said, later on when we do the runtime of all of this is going to start making a little bit more sense. But let's do a bigger example. Let's say that we've gotten down to the final step of 2 4x4 arrays. So we have 2 4x4 arrays here. And we've gotten to the final step, which means that these are all sorted at this point, just like here. These are sorted from smallest to greatest, but they aren't particularly sorted entirely. So what we're going to do is we're going to fill in these numbers. Let's say this is a 1, 3, 15, 16, and let's say this one is 10, 11, 14, 17, like so. And so what we're going to do is we're going to actually do the exact same thing we've done before. So this came in, we had two subarrays combined down into this, and now we have two sorted arrays. And so what we're going to do is we're going to combine them right here. And we're going to make a final array that's all the way big. So it's the original size here, which was the 19 total. Or the 19, the 8 total. 1, 2, 3, 4, 5, 6. So we need to divide this again. And so now what we're going to do is we're going to do the exact same method as before. We're going to grab a left cursor, and we're going to grab a right cursor. And these are just parsing the arrays, and we're comparing for whichever one's the smallest. So we have right here, we have the 1 and the 10 being compared at the current moment. And so let's move this up so we have some room whenever these disappear. Let's put that like right here. So we're comparing the 1 and 10. Well, obviously the 1 is smaller. So the 1 goes into here, into the first spot. We go ahead and cross out the 1, and then we move the cursor over by 1. And then now we compare the 3. We compare the 3 and the 10. Well, the 3 is still smaller, so we put the 3 in there. We cross it out, and we move the cursor over to the 15. Like so. And now we could do a comparison once again. Well, now the right side is smaller. The 10 is the smallest. So we go ahead, we put the 10 in here, cross out, and move. The 11 is now the smallest because the next number over here is 11. The 11 is now smallest, so we put the 11 in there. And we're going to keep doing this process over and over until we get to the very end. But I want to kind of go through the entire example so you understand what exactly we're doing here. It'll really help you get the intuition, which will help you understand the runtime a little bit later. So now we have 14. 14 is again the smallest. So we go ahead and do the exact same processes as before, crossing out, moving the cursor over, and then now we have a 17 over here. And so then we do a comparison on the left side. Well, the 15 is now the smallest, so the 15 goes in here, cross out, move. Now we have 16 versus 17. The 16 is the smallest, so the 16 gets placed here. It gets crossed out. It gets crossed out, and then the cursor moves on. But there's a special case right here, is that when the cursor moves past, and it understands that it's at the end of the array, there's nothing past here, there's nothing it can grab over here. Once it gets to this point, what it does is then it just copies the rest of whatever's over here. So in this situation, we only have one element. It just copies the 17 over. However, in some situations, it won't be that easy. We'll have maybe a 17, 18, 19, 20 over here. And so we don't keep comparing it once we run out of one of the sides because there's nothing to compare anymore. The array is finished. So what we'll do is we'll actually go down and we'll just copy the rest from the other array because it's already sorted. So we know that the rest in this side are going to be greater than any of the numbers over here. And so that's just something to keep in mind, is at some point you'll run out on one array but still have 3 or 4 elements on the other array, and that just means copy the elements all over into the final array. And now what we have is our sorted array. So that is the intuition behind how merge sort works. You take a number and you split it downward, and you recursively split it until you get to a point where you're just at ones down here. And the algorithm itself doesn't usually actually split it like so. It just understands that 0, 1, 2, and 3 are all going to be separate entities, but the human way of doing it is we have to do these splits. The computer has a slightly faster way of just guessing all of this stuff, but that doesn't really matter. That's something that's very actually easy to implement in code whenever you look up the code for a merge sort. But this is how it works. And then once we get to our final merge step, we create our little cursors, and then they just compare back and forth. And you'll notice that even in this, where there were 8, it only took 8 different tries because all we did was we went 1, then we moved over 3, so it went 1, 3, 10, 11, 15, 16, 17. It only touched everything in number of times. So even at this step, it was in. And like I said, this is going to come in important sort of a little bit later when we actually look at the runtime. But let's now look at a visualization of how this might work by a computer. So let's go ahead and create ourselves a unsorted array here, and let's start it. And this is using merge sort. And we're going to go ahead and click the sort button, and then go. And then you'll see that what it does is it first separates these sides. And what it's doing is it's actually separating. Let's slow this down a second. What it's doing is it's separating into 2, sorting them, separating into the next 2, sorting those, and then 4, and then it'll do the exact same thing for the next. So 2, 2 makes it into 4 right here. And then it's going to sort the 8 right here. So this is recursively going in. So what it does is it actually started by splitting this in half, and then it went all the way down until it got to these 2 right here, sort of like over in this example. It got all the way to right here. Then it started sorting it upwards. And that's what it's doing right now. Now it's sorting the left half of this. And it's making it all sorted. And then it begins the right half. So it takes the first 2 numbers. It sorts them. Then it takes the next 2 numbers. And it sorts them. And then now it has 2 sets of 2. So now they can set these because now they're exactly the same. So it compares them. And it sorts them again. Just grabbing the least one on each side. Puts it back up. And then now it has 4 that are sorted. So then it moves into the next spot. And even though there are 3, it doesn't always have to be perfectly symmetrical. You can have an odd number and still have this work. It goes ahead and it separates these. It sorts them back down. And then it chooses the least amount and creates a sorted side on the right. And then it does one final after this is done. Puts these all back. And then now we have 2 sets of 8. Well, this one is 7, but that's as close to 8 as we can get. And then it begins sorting this for the final sort. And now you'll notice it grabs the least amount from each side. Let me go ahead and speed this up if I can actually click on this. Yeah, right there. And then it just go ahead and puts it all back together. So that is the intuition. That is how merge sort works. Let's jump into the next lecture where we're going to be talking about the runtime and why exactly this is faster than the others.